Next question was, oh, the asteroid. Oh, you're worried about the asteroid. Oh, wimp. Well, there is an asteroid headed our way. By the way, I'm on YouTube describing this. And who here has not seen that YouTube video? Really? Okay. So this, I'll give you a version. This will be a live YouTube version of it, okay? Okay, okay. So, December 2004. I'm going to flesh it out in ways that there's no way another question can follow it. Okay. We discover an asteroid. We have a couple of data points on its position in the sky. You look at its speed, you get a Doppler shift on it. You get its direction, you plug it into the computer. There was some 20% chance it was going to hit Earth on April 13th, 2036. Did you hear about this asteroid when it was discovered? No, because that same week was the Indonesian tsunami. That same week. And so rightly so, it did not lead the headlines the way the tsunami did. However, if you did the calculation, you would show that if it hit Earth in the center of the uncertainty range, it would hit the Pacific Ocean 500 kilometers west of Santa Monica. It would plunge into the ocean to a depth of 3 miles. It would explode at that depth, cavitating the ocean in a hole 3 miles wide. Now you have a wall of water 3 miles high. What happens to that wall of water? It just spills back into the hole that was just made, splashes into itself, and rises high again. That first impact creates a tsunami that's 5 stories tall. By the way, this asteroid is the size of the Rose Bowl. In other words, it would fit neatly in the Rose Bowl the way an egg does in an egg cup. So, what? So, here's the first wave. The first wave is just from that first impact. You cavitate the ocean, it fills up again, rises high into the stratosphere, falls back, cavitates the ocean again. Now it's water cavitating the ocean, not the asteroid. That sends another wave, and this repeats. Calculations show this will repeat about 40 times. 40 times. 40 tsunamis, one right after another. What's interesting to me is that tsunami would take out the entire west coast of the United States, do $10 trillion in damage. It would make the Indonesian tsunami look like a slightly overflooding puddle. So it was a lost opportunity to compare and contrast magnitudes of disaster. It would later make the news when better data became available. But let me explain this tsunami to you. So it's a wall of water 5 stories tall. The next tsunami, 40 seconds later, because it would be pulsed every 40 to 50 seconds, the next tsunami needs that water. There's not an unlimited supply of water. The first wave has got some of the water that the second tsunami wants to use. So what happens? The first tsunami goes in only as far. It goes 40 seconds into land. Then it's pulled, 20 seconds into land, 20 seconds back for the next tsunami. So in fact, if you do the calculation, you can show the tsunami would not go past about a 1/4 mile inland. You could set up a rope, you know, like one of those club ropes, and just sit there and just watch the whole thing happen. The waves come in, they pass through the multi-million-dollar Malibu homes. The wave comes out, brings the home with it. Next wave comes, takes the home back in a slightly different shape than it was before. This process basically ablates the entire west coast of the United States. We would know this in advance, thanks to Isaac Newton and his 2 equations he developed as a 26-year-old virgin. And so, so actually nobody has to die. It'll still do the $10 trillion in damage, but we know this in advance. But I thought about it, there are 2 people who will die. 2 people. And you know who they are, okay? There's the idiot surfer who wants to get that last wave. You know, rad, man, I'm gonna, The idiots